Hello and welcome to this episode of Math with Martinez. We are in our Pre-Cal Unit 2, focusing on composition and inverses of functions. And in this video, we are going to have the objective of representing a given function as a composite function of two or more functions. So let's go ahead and turn to our notes on decomposing functions. Decomposing a function is just the process of viewing a more complicated function as a composition of simpler ones. So that's kind of the big objective here, or the big descriptor here. We're just going to take a really complicated function, like you see these down here, and try and view them as simpler functions that have been composed together. This skill is going to be used extensively when you all get to calculus. In calculus, we apply this rule called the chain rule to take the derivative of composite functions, because if we couldn't use the chain rule, finding the derivative would be incredibly difficult. So to go through this process, to decompose h of x, what we're going to want to do is find a simpler inner and outer function, g of x and f of x, in such a way that what we have is h of x will be equal to f of g of x, where, if you think about this here, g is the inside function. Let me write it like this. G of x is inside, and the f of x is outside. So let's go ahead and look at these two examples here. What we're going to do is we're going to find f of x and g of x such that it follows that definition of the composition. What's always going to be easier is to first go ahead and state what your g of x function is. So if we're looking at this function here, let's try and look at what is a function inside of another function. What I'm noticing here, I'm going to highlight in green, is that I have this quintic function, this polynomial function, inside of a square root function. So what that means is I can go ahead and let, or I might say if, g of x, that inside function, is equal to, x to the fifth minus 3, if that is my inside function, then what would be the outside function? F of x is just the square root of x, because in place of the x in f of x, we have substituted that entire g function. There may be more than one way to decompose this function, and so if that's true, just make sure you start with your conditional statement of what the inside function is going to be, and that it does work out, that the composition actually does give you that initial function. So maybe even try it. See if you guys can come up with another one over here. And we're going to turn our attention to B. Again, we're going to try and identify what would be the inside and the outside function. So a function that I'm noticing that's on the inside right now is this, which is in the groups, in the grouping symbols right here. So we have that if our g of x, our inside function, is x plus 3, and then what's on the outside? Let's highlight everything that's on the outside. 2, and that quantity is squared, minus 13. So what we would say is then f of x is 2x squared minus 13. And that works out because if this is my input position right here, this goes in that spot and it would give me this original function. So there you have it, ladies and gentlemen. Inside and outside functions thinking about your composite functions like that allows you to decompose them as well. This is, again, a skill that we are practicing here in pre-calculus to get you ready for calculus because it is used extensively there. If you had any questions while watching this video, please share them now. And until next time, stay fired up.